Hello. Oh, can you? Okay. Oh, good morning. Thank you, Charlie. Okay. Okay. I apologize. This is a late start. I hope you got the message. Thank you, Charlie. Good morning. Good morning, Alyssa. Good morning, Charlie. Good morning, Daniela. Good morning, Lakshmi. Good morning. Oh, okay. Oh, okay. Cool. Good morning. Okay. And you can, right? Oh, more people coming. Sorry. Okay. Okay. I'll try to just get rolling. And if someone could just confirm that you can hear me, I think you can, but yes. Okay. Thank you, Charlie. Appreciate it. And thank you, Alyssa. And thank you, Vivian. Thank you, Sohad. All right. Awesome. Awesome. All right. So yes, late start this morning. I apologize. And I know we didn't have synchronized class on Monday. There are a couple of things are happening. Sorry. And I'm having some technological issues I hope don't affect us today. I'll just try to be serious and get straight to it. Well, okay, let me say hello. Oh, yes, you can. Okay. Good morning, Alyssa. Good morning, Charlie. Good morning, Noel. Good morning, Daniela. Good morning, Soad. Good morning, Lakshmi. Good morning, Vivian. Thank you, Charlie. Thank you, Alyssa. Thank you, Soad. Thank you, Vivian. Thank you, Daniela. Okay. Again, oh, and more people coming. All right. I'm kind of assuming or thinking that a lot of you got the message that we started late this morning. I hope you did. But I appreciate your indulgence either way. Here's what we're going to do. I want to dive straight in. What you'll notice on Monday, hopefully you saw the video from Monday. I think it will, if you haven't still yet, I mean, it will help for this like upcoming stuff that we have. But here's the main, I'm going to try to not like, I want to be as productive as possible today. Here's the highlights. You will notice hopefully that I put a practice exam in your Google Stream on Monday. Oh my God, you really did watch it. Wow, thank you. That's wow. Okay, thank you, Danielle. That's hilarious. Okay, and there was a little bit of like more joking around probably than there should have been on Wednesday. I mean, in the other class when you guys weren't here, I'm going to try to be very, I mean, I love the joking around, but I understand some people could be concerned about time issues and stuff. So I'll try to be as efficient as possible today. Here, the main reason you might want to watch the video, well, clearly Daniela did, and maybe many of you did. The main reason to watch the video for Monday when you get a chance is just that I think I did sort of give some observations and instructions or expectations about this exam that you're going to have. Now, and I don't want to repeat myself. I want to try to prepare you as best as possible with the material for the exam. That's what we're going to do today. In fact, but as far as, so just to remind you though, what's going to happen is a week from today at night, like after classes and after labs and stuff, or early in the evening, I'll post your midterm exam. Again, we'll talk about it even more on Monday in class. We will talk about it even in Wednesday in class of that day. I will answer any and all questions. The more questions, the better. I mean, Monday and Wednesday. I'll try to put more logistics into Google Classroom to make it as clear as possible. I know I'm in the halo. I mean, I want to do as much physics today as possible for that exam, but just again, it just isn't over. And if I seem a little stressed right now, I apologize. It's partly just because there's technological issues and things happening on this end, but also I want, as I tried to explain on the video, I want your exam experience to be as high productivity, with as low stress as possible. Okay. I mean, I'm not looking to make your lives more stressful. There's some extent to which there's no avoiding that I will, but the main thing, okay, what I'm really trying to get at here is there's a practice exam that was put in your stream. Let me reinforce that practice exam is not for me, it's for you. Like, you never turn it into me, you don't get a grade on it. It is there to maximize your expectations of the actual exam, to minimize surprises. if you get updates to that practice exam between now and Monday or now Wednesday, any of those updates will just make it that much more similar to your actual exam. The practice exam is meant to be as similar as possible to your actual exam. It's like, it literally is like my rough draft for your actual exam. As we get closer to your actual exam, if I realize like, oh, we didn't really explain this well enough in class, or they're having difficulty with this over here, or we really emphasize this, the more I realize I have to adjust your exam to wherever it is that you're at right now, the more I'll try to then put those adjustments into the practice exam so you can see in advance, okay? Your actual exam won't be 100% identical to the practice, but it'll be darn similar, okay? Again, with your actual exam, it'll be posted Wednesday evening. I'll be more specific about the time as we get closer, but the actual exam will be posted Wednesday evening in Google Classroom, in just like one big homework assignment. Only it's an exam, not a homework assignment, but that's like sort of what it'll look like. I mean, it'll say exam on and everything, and then you do it on your own time, in your own way, with whatever resources you want, and you turn it in the following Monday before, right before class period. Again, we'll talk more about that as we get close. The one thing is, I am strict about that. You can't turn it in late, and you do have to show up to class on Monday. I'll repeat that as we get closer, but your responsibility to the exam continues through showing up to class Monday, and you can't turn it in late. Like homework, you can turn in late. I'm very loose about a lot of things. You cannot turn the exam in late because it's not fair to your peers. But I'll remind you that as we get closer. But so, and your job, as I tried to say in the other video, your job is to show as much neat, thorough, clear, complete work as possible on the document that you turn into me as your exam, like as though it's like big, just homeworks strung together. Like, again, I say all this on the video, so I don't want to repeat myself right now, but there's no way you can cheat on this exam, because anything that you would think of as cheating, I shouldn't say that, that's a little strong, but almost anything that you might normally think of as cheating, you're allowed to do for this exam, including helping each other, including going on the web, including opening all that. It's just that by the time you write out your exam with your name on it and submit it, everything you write out, you need to understand. You cannot write out things that you don't understand, and I will know the difference. And the way you're going to show me that you understand what you're writing is you're going to make it as detailed and as thorough and as clear, possibly even as colorful as possible. Like your exam, think of this almost more like poster presentations on a piece of paper, or on many pieces of paper, of how much you understand these solutions, okay? Or think of it as a research paper or something like that. Like, okay, all that said, what we're going to do in this period, just to give you an idea, I'm going to go over one of the problems in your practice exam right now. Like one of the problems in your practice exam, it's one of the harder problems. It might even look intimidating to you. It might look harder than anything you think you've done so far. I'm going to walk you through it right now, like in a minute. In fact, here we go. I'm going to walk you through the solution to one of the problems in your practice exam. I'm going to tell you where to turn. Okay. Hopefully you have the document. I'll check the chat in a minute. Hopefully, I think you do have the document in your stream. I'm going to walk through the solution as best I can. I think I still have enough time to do it. And I'm giving you the solution. I don't want this to be a trick or a surprise. I'm giving you the solution. On your actual exam, your problem will look darn similar to this one. Like I might change the numbers or something like that. And this will confuse some of you. When you get to the actual exam, you'll even have this practice problem sitting there with a full solution to it. Now, I'm not going to do this for every single problem in your practice, but I'm going to do it for some. Your goal is to understand this solution and then give the solution back to me in a manner that shows that you really understand it. You see what I mean? Like I'm almost so it's going to even seem confusing to some of you, like I'm literally giving you the answers right now. Just like you're literally going to be able to share answers with each other when you go home for the weekend for the exam. But the idea is for everybody to get to understand what they're doing so well that by the time every person writes out their exam and submits it to me, you honestly know what you're doing And you can get that across because you're breaking it down into so many steps and putting it so in like your own language and your handwriting and your blah, blah, blah. Okay, you get it. So, and I cannot guarantee that I'm going to give you solutions to all the problems in this practice exam, but I'm going to give you some. I'm going to give you one big one right now as an example. And I'm also going to tell you that the more that you work with this practice exam at home on your own time, like this weekend, or I mean, there's no other homework or anything like that. And I wouldn't, by the way, I would not, you can still turn in other homeworks like after this exam is over. So don't you could scramble to try to catch up on homeworks to understand the material, but really I would make don't worry about prior grades or prior things that you think you owe me. Just this weekend, just work on this practice exam and try to understand everything in it as best you can. And when you come in Monday of next week, the more specific questions that more of you can ask about the practice exam itself, the greater number of tighter specific questions you raise, the greater number of tighter specific questions I'll answer in class. And I'll give you as many answers as I can. As time allows, I will. I won't guarantee that I'll give you all the answers because I don't think we'll have time. But so it's like sort of up to you to manage this whole process. All right. So in a moment, we're going to turn, and of course you can stop me today and ask questions today too. I know I'm being all jumpy and jittery, but I'm going to turn, and I'm intentionally not going in order in this exam. I'm intentionally turning to one of the problems that I think looks harder and is bigger to kind of show you the experience, to show you that if you're calm and you step back and look at it, like you have everything you need to solve it. And you certainly will after I do it today. So let me just, so I'm going to, I'm going to look at the chat, the aquatic. Okay. All right. I'm going to, the problem that we're talking about, I'm going to switch back and forth between screens, I think, for a minute. I'm going to show you on the screen what problem I'm talking about, but hopefully, and maybe I can get confirmation in the chat. Maybe someone tell me in the chat, like, yes, we have the practice exam. Yes, we know what you're talking about or whatever. I'm going to show you on the screen what problem I'm talking about, but then I'm going to assume like you have it in front of you so that then I can, turn back to my pad and solve it. So what I'm talking about is this. I think this is it right here. Yeah. Okay. Oh, are we there? Okay. It looks, yes. So yes. So what's showing up on your screen right now, hopefully, again, I am having some technological issues that are making me nervous. But I think what you see on your screen right now is part 3, problem 2. It's called Wile E. Coyote. It's worth 20 points. Again, this is pretty much like, there'll be some changes, but this is like an example of a problem that will be on your exam. You'll also notice in this practice exam, I believe, I can't remember. I believe like we give choices, like where you had to do problem 1 in this exam, but then you could choose between problem 2 or problem 1 of part 3 or something like that. Like something like that will happen on your exam as well. Like there'll be certain things you have to do, and then you'll get some kind of choice. Okay, wait, I'm looking in the chat to see. I'm all confused. Oh, and the yes from Charlie and the yes from Daniela, I'm taking to mean that we're on the same page with this exam. Okay, thank you, Charlie and Daniela. I mean, serious, thanks. Okay, so this problem that you're looking at your screen is, again, hopefully you take it out on your own right now and you look at it, because I'm now going to switch screens again. And I'm going to try, if I can, I'm going to try to show you my model of like what I would expect you to do as a student to respond to this. And this is a fine line that we're walking here. I have to be careful again. I'm showing you my model, right? Like I'm pretending I'm a student. Here's the ingredients we're looking for, in expressing my response, my answers to this question. It's a model. Like if you literally just identically copy exactly what I'm doing, you're making a mistake. I promise you. You don't want yours to look exactly like, of course, the physics have to be equally correct, but you, on the one hand, don't just, you're going to use this model that I'm giving you to study. It's like a sample problem in a book or whatever. And ideally what you do is after you look at this and you're like, oh, I understand it. Yeah, I get it. Then ideally what you do is you try to do your own without looking. I mean, like you try to write out your solution on a piece of paper without looking at mine, not because you're not allowed to look at mine, like you could, but if you try to do without looking, you'll really know if you really get it or not. And then like when you're stuck, you can look back and stuff like that. But I really recommend to all of you, again, the way to study for this exam is to just use the practice to practice, right? Oh God, I think I just lost my screen. And you're allowed to look at my stuff when you do it, but I'm recommending to you, the more you don't look at my stuff while you're doing out yours, the more you will necessarily be showing your original understanding of the real work. And, go back and forth as much as you need to until you can do it without looking, and do rough drafts until you have a final draft that you hand in. Again, it's a fine line, and the converse of that is, I'm about to do this. I know I'm sort of stalling, but I'm about to do this. But I also don't want anybody to say, like, when you hand in your exams, like, what am I trying to, like, the goal is not for yours to look identical to mine. The goal is for yours to capture all the same information as mine in your way. So I might not do this perfectly now. I mean, I'll try. Okay, anyway, enough talking. So I'm going to go switch screens. But certainly the style and the format of what I'm going to try to do is what you try to do. All right. I might even need your, all right. So I'm going to go back to. And please do in the chat, stop me if either you have no idea where I am or you need me to go back, or also you can stop me to say, like, we get it. Can you please go on? Like, that's fine too. Okay. So. Okay. 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 Oh, sorry. Okay, just note, so sorry I'm taking so long time. Okay, so note what I've done first, like, and again, please, if anybody's still paying attention, this is what you would do on your exam. Like, notice I've got blank paper here. You would have blank paper as though it were a blue book. You would, just like we were doing homework, you would make the problem clear, right? Like, this is presumably not the first page of my exam. This would be like somewhere in the middle of my exam. And please do number the pages. But so notice at the top, I'm saying like part 3, problem 2, Wile E. Coyote. I'm making it totally clear what problem I'm on. Now I'm not copying and pasting all the words of the problem. Like, I'm deliberately not copying, pasting that. And I'm not typing, and I'm not writing out all the words of the problem, but I'm giving enough information. I'm giving all the relevant information as clearly as I can in my own language here at the bottom of my board. Hopefully you can see. Yeah, okay. And so I'm about to make the question clear in a second, but first of all, I've made the facts clear and I've provided a diagram, right? And notice that even in my diagram, even though it happens, there's going to be a question about this in a minute, but whether or not there's a question, in my diagram, I made a coordinate system. I labeled my axes. And notice the choice I've made here, and you don't have to make this choice. I mean, it's going to be a question moment. But notice I'm deliberate. I'm making a coordinate system. I'm assigning plus and minus to each of the 2 possible directions along each axis independently, right? Like, this gets back to something we first were said in class last Wednesday, and then I said in the video on Monday. Like, this problem perhaps looks intimidating because it is a 2-dimensional problem. We're into 2 dimensions now, kind of like lab 3, kind of like lab 4. But the principle here is that any 2-dimensional problem is really just 2 1-dimensional problems occurring simultaneously yet independently. Like, that's a principle that, and I might even write that down at some point in my solution. But I'm just saying, like, we've got we have all the equations we need to deal with physics in each dimension one at a time. So here, there's a dimension happening like this, and there's a dimension happening like this. They happen to be happening at the same time, but they're not affecting each other. So whatever, I'm going to do physics like independently on each axis, okay? And thereby, I'm going to label each axis. I'm choosing a coordinate system. I'm saying in the horizontal axis where there's west and east, like I've provided a little compass here, and I'm saying anything that goes to the east is going to be called positive, and anything that goes to the west, whether it's a displacement or a velocity or an acceleration, anything that goes to the west is going to be labeled negative. And maybe that's an obvious choice, but it's a choice though. And then notice this little subtlety. I'm deciding, and you have to make a decision. It might not be the same one as mine, but I'm deciding right from the get-go that anything that goes down, like, so then there's this axis, the up-down axis, right? And I'm deciding that anything that goes down, I'm going to call positive. You don't have to do that. You might find that weird. Maybe it is weird. I'm calling anything down positive, and I'm calling anything that goes up negative. Now, I'm not doing that to be weird. I actually think that's a smart, convenient thing to do. I'm going to do it like as a test taker here, as a problem solver, because I don't expect, it doesn't look like anything's going to be going up in the problem. It looks like something's going to be falling down and there's going to be physics to be worked out. It looks like anything that's happening is going to go down. So I'd rather make down the standard positive direction because I'd like to deal with as few negative signs as possible, right? You might decide to make down negative because that just seems more natural to you. And that's fine, as long as you're consistent. But then then anything that's going down, you're going to have a negative sign for. Okay, so whatever. I've just made this decision at the beginning. I would do this for any problem. Technically, this is step 1. Like, I've done step 1 of our problem solving procedure here. You might even label it that way for your own sake or for my sake. Like, so I've done, excuse me, I'm sorry. I've done like diagram and fact pattern, right? Okay, so I'm turning the page. Stop me if that's not okay, but I'm turning the page. And the very next thing I've got to do, like, that's setting up the problem. The next step I'm going to do, and again, you don't have to write the titles of these steps out for me, but you might want it for your own sake to keep track, because I am looking for all these steps. So my next step is like WIQ, what is the question, right? And what is the question? And what is the question? The first question is, oh, okay. Okay. What assigned coordinate system? Okay, notice, and I'm just trying to show you how to take an exam for me, basically, right? Notice really in my diagram, I sort of had already done this, but I'm just being as clear and explicit as possible. Since the question is what's the coordinate system, here's my coordinate system. Okay, so I've answered the question. In fact, technically, since that is my answer to the question, I might even like circle it or something. So just please notice again, I can't emphasize this enough. I'm already telling you the physics here. You're going to work together and stuff. You're going to be able to go online and stuff. Like the physics answers are going to be known. I'm going to know the physics answers to these questions, and I'm going to know that you have access to the answers. So your goal here is not just to spit out answers. Your goal is to be as explicit and clear and thorough as possible, right? Again, this is a little bit more like if you like an essay assignment or like a poster presentation of your understanding than anything else. What I'm getting at is where people lose points usually is not because they have wrong answers. It's they lose points if they're not clear or they don't make the reading easy for me or something, or I'm suspicious as to like whether they really understand what they're writing or not. Okay. The way you lower my suspicion is make it as personal and communicative as possible. So notice, please, even though I know I'm saying this over and over again, but this is where people have lost points in the past. Notice you're using blank sheets of paper as though they were a blue book. You are presenting all the work to me on these blank sheets. Have in your mind the goal. What you want is for me to be able to have an easy and clear time grading your work as possible without me having to go back and forth between documents. Like literally, I mean, there's a lot of reasons for that don't just have to do with my convenience, honestly, but some of them do have to do with my convenience, and some of them do have to do with how efficiently I can get these back to you. So really have in the back of your mind, you want to give me something that stands on its own as a physics document that I can just read it and follow it and get that you get it without me having to look anywhere else. That's what I'm trying to do for you right now on here. Like I'm trying to be like, okay, there's the right, but I'm not copying and pasting electronically. I'm not copying and pasting the questions into the blue book. The reason for that is if I did that, that doesn't show that I understand them at all. Like you know what like I'm jotting down, okay, the question is assigned coordinate system, and I'm jotting it in a way that shows. Anyway, I think you get my point. So that's question A, done. Now we go to question B. Sorry, question B is for the time. Okay, and you notice these early questions, it's not meant, well, all right. So B is for the time interval from t equals 0 to t5, how should the velocity and speed trend? Okay. Okay, now, okay, this is still sort of like a warm-up question. It's not meant to be a trick. It's meant to get information out on the table that we're going to sort of use for maybe the harder parts of this whole thing. Wait, did I skip? No, okay. From t equals zero. All right. So, and I have four choices here. So this is all about whether velocity and speed are decreasing or increasing. This involves looking at the signs. Like remember, the distinction between velocity and speed is that velocity is speed with direction. And you might even, so that was the question, right? I might, Okay, I'm getting a little sloppy. Here's an example right here, if you're paying attention, where I think you could do a little better job than I'm doing. I'm being a little sloppy here. Let me explain what I'm saying. So what it's asking is what's happening to the velocity and the speed in the first 5 seconds of the roadrunner's motion. Let me back up for a second. If you look at the facts, according to the prior page, the facts are that the roadrunner starts like at t equals 0. He has a velocity. The roadrunner has a speed of 25 meters per second heading to the east. We decided that anything heading to the east is called positive, right? Okay. So right at that moment, at the beginning of this experiment, the roadrunner has a speed of 25 meters per second and has a velocity of positive 25 meters per second, right? But as an acceleration of 5 meters per second pointing west, the problem says. So I should really make that clear somewhere in here. Like according to our coordinate system, once we assigned positive to the east direction and we assigned negative to the west direction, then if you really think about it, and I do want you to think about it, make sure you're clear on this. And again, you can ask questions today, or you can ask questions Monday, or even Wednesday. Or even Wednesday. The test won't be posted until after class Wednesday. So plenty of time to think about this and ask questions. But what I'm really saying here is, if the problem said that the roadrunner was heading to the east, had a velocity to the east, but had an acceleration to the west, according to our coordinate system, that means the velocity was positive, the initial velocity, and the acceleration was negative. What's acceleration mean? It means change in velocity. So what's really happening here in English is the roadrunner's velocities are going like positive 25, positive 20, positive 15, positive 10, like every second, the roadrunner's velocity is decreasing, is subtracting 5. Why subtracting? Because it's acceleration of -5. Why negative? Because the acceleration we were told was pointing west, and we've assigned the negative sign to the western direction. So this velocity, this roadrunner, its velocities are going like positive 25, positive 20, positive 15, positive 10, etc. Okay. So I say its speed, the absolute values of those numbers, the magnitudes of those numbers are certainly going down 25, 20, 15, right? And the velocities, they're all positive numbers. They're going down too, positive 25, positive 20. Like it's hopefully, so I'm saying my answer to this question is that both the velocities and the speeds for this section of the trip are both decreasing. I want decreasing, like that's my answer. It's circled. And notice I'm trying to do all my steps. Like I have the diagram and the fact pattern. I have the what is the question. Then I have the general definition or principle, which is I'm reminding me myself or the reader, like here's what average speed means. Here's what velocity means. I'm putting some comments like in English or in my own way or in different colors. Then I have PAW, like particular application and work. Right. So I'm like writing my thoughts about this particular problem. I'm giving examples of velocity numbers. Mine's becoming a little bit of a mess. You would do it a little bit differently, your own way, but I'm showing my work here and my thought process. And my final answer is circled. Velocity and speed are both decreasing. Now I want to I'm looking at the time. Okay, we've got time. I want to be very clear about something. I'm really trying to show you what I'm looking for in how you answer questions on an exam. And again, I might sound a little stressy right now, and I don't mean to be. I certainly don't want you to be stressed. But notice this. This is not a hard question. I mean, I should never say that. But once you think about the question or once you see what I'm looking for, please notice it's not meant to be a trick. It's not meant to be a trick. The answer is just the velocity is going down, the speed is going down. You might even think like, duh, like, I don't even know what there is to say about that. Like, well, this is what to say. But you might be thinking like, he's making such a big deal about this. Like, it's not that. You might be thinking like, I almost don't even get what the question is. Like, yes, the velocity is going down, the speed is going down. And in the first question I just asked, like, to make a coordinate system. If you're thinking like, I don't even get what the big deal is about this, or if you were to get to the test and be doing this, don't look for tricks. Don't think it's got to be harder than this, because physics sometimes does feel harder. What I'm telling you is that most physics problems start with some basic steps and some things that are, they're not trying to trick you. They're trying to ask basic things, because then we're going to put the basic things together and solve something maybe a little bit more challenging. That's what's about to happen in the next couple of steps. In fact, the very next step is not a much harder question, but you're going to get a slightly different answer for the next step in the question. It's like, in other words, this is almost setting up a contrast. I'm just trying to say, you do want to overdo this. You do want to be over clear, over complete, over thorough, but don't overthink it. It's not meant to be any harder than it is, but it does progress from simpler things to more complex things. That's the nature of physics. So just sort of trust that and understand that going in. Again, it's why I'm giving you the sample here, but okay. Okay. But so there's nothing like, we're not saying anything like surprising or weird. We're just saying the velocity is going down, the speed's going down. The numbers are like 25, 20, excuse me. The numbers are like positive 25, positive 20, positive 15. Okay. And then the next question is, sorry, is C. Okay, just slightly harder. So the next question is C. Okay, now I'm going to cut to the chase here. Like here again, you can write out equations. You can show the logic again. I'm going to cut to the. I'm going to first of all, I'm going to give you the answer. Okay. Now again, I'm being a little quicker here. I'm kind of assuming you're getting what, and again, I would encourage you to be maybe more clear or more thorough, or maybe go in a different order from the way, maybe you might write your equation first and then write the explanation that I'm writing here. But well, I'll finish it up. I'll write the answer. Sorry. What I'm saying here for this question, I'm looking at the time. I'm saying now for that next 5 seconds, like in the t equals 5 to t equals 10, now I think the velocities are continuing to decrease. The velocities are continuing to decrease, but now the speeds are increasing. Okay, slightly different situation now. Slightly surprising, maybe, unless you think it through. Like, or we're trying to show a contrast here. Well, now again, you maybe you want to write this out in a different order from the way I did. Maybe you want to think about it in a different order. But what I'm saying is, if you think of the logic or the equations, if you want to think of the the equation average acceleration equals change in velocity per time, like the equation I've written at the bottom of the page here. That's just the definition of average acceleration. You could plug in the numbers and see what I think the logic tells you, which is, look, this object, the Roadrunner, started off with an initial positive velocity, eastward pointing velocity of 25 meters per second. It's constant acceleration. It's at a constant acceleration of 5 meters, of negative 5 meters per second squared. That is, it's losing 5 meters per second of velocity every second. So it's velocity, and it's doing that constantly. It's constant acceleration. So the numbers went like 25, they went like positive 25, positive 20, positive 15, positive 10, positive 5, 0, right? According to the equation, or just according to logic, like it started with 25 units of velocity. It lost 5 every second. So within 5 seconds, it's lost all of its velocity. It's got 0 velocity, but the problem says that the acceleration remained constant. Like it kept on doing that same pattern of motion, like forever, as far as we're concerned. The acceleration continued to be negative 5 meters per second squared, i.e. every second, this thing continued to lose 5 meters per second of velocity. So once it's hit 0, that doesn't mean like the problem dies forever or that it never moves again. It means now the velocity is going to negative 5 and then negative 10 and then negative 15, i.e., or in other words, the Roadrunner turns around and starts coming back. Do you follow? Like the Roadrunner is now moving back at numbers like negative 5, negative 10, negative 15. Again, you can use the equation to show yourself that. You can use the equation to show yourself that within 5 seconds, the Roadrunner is at a velocity of 0. So the next second, it's going to be at negative 5, et cetera, et cetera. That's what the math says. You might think, wait, what? The Roadrunner's turning around. It never says that in the problem. What it says is that its acceleration is constant. If it started by moving positively with a negative acceleration, that means it's eventually going to be moving negative. One last thing, you might think, well, this is like all weird and, contrived, like this would never happen in the real world, or like it doesn't seem, this is exactly, if you think about it, what's happening here is a perfect analogy to what happens if I throw something up. If I throw something up in gravity, I give it an initial positive velocity, but gravity produces a constant negative acceleration. So I throw something up, it's losing velocity, slowing down. Then it gets to 0 velocity and gravity continues to pull on it. The acceleration continues to be a constant negative number. So now the thing reverses direction, starts coming down. When something goes up, it's losing speed, and losing velocity. Then it naturally, of its own accord, starts coming back down with negative velocities. So what happens is it continues to lose. So when you go like this in the real world, when you throw something up in gravity, it loses velocity, continues to lose velocity. But speed-wise, it loses speed, then gains speed. Right? It's always losing velocity, whether it's going up or going down. But on the way up, it's getting slower and slower. On the way down, it's getting faster and faster. That's exactly what's happening to the Roadrunner here. I'm saying the Roadrunner is like a horizontal analogy or a horizontal model of exactly what happens vertically under gravity. Okay? And it's just trying to show you that. We're going to go on in a second. But so the answer to and you can explain it 1,000 different ways. And, the more originally you explain it, or the more thoroughly, like the better. But the answer to this question is that now the velocity is still decreasing. Velocity is still changing in the same way because acceleration is a constant and acceleration is changing velocity per time. The velocity is still decreasing, but now the speed is increasing. That's the answer to C. Now, let me just make sure. I hope that's clear. I'm going back and forth between screens, so I'm a little bit. Oh, let me look in the chat. Sorry, I see you said. Oh, good. Yeah. Wait, so using the coordinate system. He's moving east. Yes, exactly what Alyssa said in the chat. Because of our coordinate system, once his velocities become negative, that means he's moving west now, or the other way. Yes, so as Alyssa said, using the coordinate system, he's moving east and then moving west when the velocity turns negative. That's precisely right. And the reason we know all that, like from the get-go, is because we're told that acceleration is a constant. So we were told that he's always losing velocity. And if that's true, that actually means he eventually has to turn around. Excuse me, turn around. Oh, good question, Lakshmi. So Lakshmi asked, what would happen if the person was moving east and then moving south instead, moving east and then moving? Then we'd have to add those two displacements like vectors, like I did in the video from Monday. If you literally mean south, like if you literally turned a corner, and went into a different axis, we would have to add vector components, kind of like we did. That's a really good question. That won't happen in this problem, but yeah, if something actually like went that way, and then like if something moved in 2 dimensions like that, to get its total motion, we would add the vector components together, like using SOHCAHTOA and Pythagorean theorem, kind of like I did in the video Monday. And I will get back to things like that, like elsewhere in the exam. So, but that's a really good question. Okay, great. Thank you. I was just going to say, thank you, Lakshmi. And really, especially when we're doing, I really appreciate all these questions, guys, are really, I really want to feel like I am communicating to you. So I really appreciate the questions. And I really appreciate that Lakshmi just like acknowledged, like closed the loop on that question. And she gets points for that. And I'm thinking that I answered Alyssa's question too. I think maybe she'll tell me. But all right, now, awesome. You see, it makes me feel so human. It's calming me down. I feel like I'm doing better on this exam already. Okay. And please understand again, I know I said it on the video, but remember, you are not competing against one another in this situation. I know you are in life in some ways, it's unavoidable, but remember, every single one of you could get an A on this exam and I'd only be happy. Like, I'm assuming it, was legitimate. So we're here to maximize our performance and our understanding all together. It is not a competition between you guys and me. I'm not trying to see you do badly, and it's not a competition amongst you guys. It's us trying to understand physics. Or just to remind. So anyway, so if I sound nervous, it's because like I want you to do well, not for any other reason. Now we have this class ends at 12 minutes, right? Yeah, we've got 12 minutes. Now I'm going to do the hard part of the question. Okay, so I might rush this a little bit, and again, if I don't, we can finish next time, but. So this is all sort of building up, trying to get us to understand what's going on, building up to the sort of central point of the whole thing, which is D. And here's where you really would want to show a lot of work. Yeah, and then there even is an E, but E is not that bad. The main point here is D. All right, so D. And I may have to go a little bit quickly here, but consider, so D is how high? Now, please also notice, since I've got 11 minutes, I tried to sort of drag out my explanation to you guys about just how to write your answers in the exam and so forth and so on. Now you got that point, hopefully, here comes some harder physics. What I'm going to just try to do is give you the physics here. Like, in other words, I'm going to sort of stop. I'm going to write out all the stuff right now so that you have it. And I'm not going to make as big a point of explaining the style of exam. I'm just going to do the physics out now so that you have it. And then I encourage you to think deeply about it when you go home or when you're practicing this or, talk to your friends. But, okay. So how high is Cliff? Okay, I am going to have to go to the next page quickly. here's my first point here. We're figuring out how high the cliff is, assuming like the Roadrunner successfully, I mean, the coyote successfully like drops this weight on the Roadrunner. So we're assuming that the weight hits the Roadrunner. What, I mean, that's the point of the problem. What does that mean? That means that the weight and the Roadrunner arrive at the same place at the same time. What that really, that's key. That means that this motion of the weight occurs independently but simultaneously with this motion of the Roadrunner. Like it's two different physics motions, this motion and this motion, both of which follow their physics equations, their physics rules. But the point is that they're both happening at the same time. So my strategy for solving this problem in the 9 minutes I have is I'm going to figure out how much time it must take the Roadrunner to get to the cliff, assuming physics equations and all the facts I was giving. I'm gonna figure out how much time it takes the Roadrunner to get to the cliff, and figure that the weight must fall in that same amount of time. So that so I'm going to use time as the link between the two independent one axis motions. Okay, so. And this is all, everything here is constant acceleration, right? These are all the beliefs that we've ever established about constant acceleration. All those equations hold true here. So like in the x direction, this is Roadrunner, I'm talking about Roadrunner, x equals 1 f(at) squared plus v naught t, and I just put little x's there to just remind myself I'm talking about all in the x direction here. So x equals 1/2 -5. Oh, sorry. And the x was given in the problem as 40, I think. Yeah, 40. So quickly go on the next page. If you want me to flip back, I will, but now I'm going a little bit fast here, I recognize. But again, I'm just going to get this down so you can see, and then you can think about it. But I'm solving for the time. This is a quadratic equation, so I'm factoring it. Very quickly, and I'm going to say this quickly again. So I'm solving for the amount of time it takes the coyote to, the Roadrunner to get to the position of the cliff. I'm getting two answers for the time. Why am I getting two answers? Well, mathematically, I'm getting two answers because it's a quadratic. Physically, if you think about it, it's going to ask this in the next question. If the reason I'm getting two answers is because we just realized a minute ago that the coyote is going there not the coyote, the roadrunner is traveling east and then it's going to turn around and travel back west. So there's 2 times at which he could be underneath the cliff. Like the physics knows the math. He's going to either get there in 2 seconds or in a total of 8 seconds, he'll be back going the other way. Either one of these answers is valid. What do I do with these times? I'm saying now that the weight must fall in the amount of time that the roadrunner takes to get there, either 2 seconds or 8. There's 2 different possible answers. So the weight fell in constant accelerations. Notice I'm doing the same equation now, but I'm applying it to the y-axis. Same equation, but different facts. The facts of the weight. The weight fell a height of y. I don't know what it is. That's what I'm looking for, y. But it fell in gravity. Remember, I called downward positive. And gravity is approximately 9.8 meters per second, which you are absolutely welcome to approximate as 10. It'll say that in the front of the sheet. The time, well, one possible time is 2. And the weight is dropped from rest. So that's 0. I'm going to flip back this bit. We have 3 minutes. I'm going to flip this back in a second. I'm just showing, or I do the other answer, y equals 1/2 10. And that's 64 times 5. Okay, now I did this fast. Many of you may want to think about this at home, what I did. But I've got 2 minutes. Let me just summarize what, and I can obviously flip the pages back if you want. Here's what I'm ultimately saying. But that's the problem. That's the hardest part of the problem. It's a lot, maybe, but it's as hard as it gets. What I'm saying is, if I'm this cliff is either 20 meters high or it's 320 meters high. Put another way, this problem will work. The coyote could nail the roadrunner from a 20-meter high cliff or a 320-meter high cliff, as long as he's, depending on whether the roadrunner is on its way out or its way back when the roadrunner gets hit. If we're assuming that the whole situation is just like this, boom, then the cliff is 20 meters high. But if we're willing to have the situation be this, like that, then the cliff would need a lot more time and it would be 320 meters high. Those are the 2 answers. E of the problem says, what if the roadrunner has to obey the following rule? Whenever he stops moving, he'll never move again. In other words, let's assume now realistically the roadrunner is never going to come back and has to be hit on the way out. Then the answer is 20 meters. Okay, I'm not writing it down now, but the answer to E is, if the roadrunner has to stop forever when it stops, if the roadrunner can only be hit on the way out, then the answer to this whole question is 20 meters. Okay, that's the whole problem. That's how you do it. I think it's one of the harder problems on the exam. Every problem looks really hard at first, but if you just break it down and you're patient and you do it bit by bit, you have all the equations you need to do them. I'm gonna stop. Again, please just look out for, I may send adjustments or updates to the practice exam, but use the practice exam to study. If you look at something and you have no idea what it is at all, do something else. And bring questions next Monday and so forth, or email me questions. But that's what I'll hang out for a second in case there are questions, but thank you for being so patient and understanding and everything. And that's it. So I'm done and I'm stopping the recording, but I'm here.